Okay, so first we will see about what is avalanche breakdown. So this is already known to you, but anyways we'll revise this concept again. So as you increase the reverse bias voltage, the electric field across the junction will increase correspondingly. You know, voltage develops electric field, and if you have electric field you will have voltage. Both are got each other, so that is reciprocal. Okay, if you have voltage you will have electric field, if you have electric field you will have voltage, both are related. So here if I apply a reverse bias voltage, the electric field is set up strongly across the PN junction. So what happens, the thermally generated carriers while traversing the junction acquire a large amount of kinetic energy from this field. So since you have electric field constantly supplying energy, when the majority carriers are going to cross the junction, they will acquire energy from this electric field. So as a result, when the velocity will increase, so when they have more energy, they can move faster. So velocity is going to increase. So these electrons will collide with other atoms which are present nearby, disrupting all the covalent bonds. Okay, so these electrons are going to disrupt the covalent bond. So they will try to break the covalent bonds and create new electron hole pairs. So these electrons are moving, they will collide with immobile ion, generating more number of electrons. So as I told, one electron will go and hit an immobile ion, you get one electron, it becomes two. Two will go and hit two, two becomes four, four becomes eight, eight becomes 16. So it is going to increase in powers of two. So that how they are getting energy, because I am having a constant reverse bias voltage applied across the region where the electric field is set up. So these new electrons will acquire so much of energy from the electric field and collide with immobile ion, generating an avalanche of electrons. So initially one electron will start the process, but it will become infinite number of electrons produced after this avalanche breakdown has happened. So this process is cumulative and results in generation of avalanche of charge carriers within a short amount of time. So this mechanism of multiplication of charge carriers is called as avalanche multiplication. So when you have more number of electrons, when you have more number of electrons, you will have more number of current. So that is the reason why they are saying in reverse bias, after breakdown has happened, enormous amount of current will flow through your device. Okay, that is why you see in this graph, after till breakdown, the current is very minimum. But after breakdown, you see voltage becomes constant and current starts increasing enormously. That Zener breakdown or avalanche breakdown, the current will become enormous because of multiplication of charge carriers by a process called as avalanche multiplication. So this when avalanche breakdown happens, your diode becomes unusable. It breaks down completely because enormous amount of voltage is applied across the junction and heavy current flows through your device. So V is also high, I is also high, power is also high. So the diode will completely break down. The diode will completely break down. So some people were studying how to how to ensure that breakdown should also happen, and the breakdown should also happen, and the diode should also be used